Thank you very much. I'm going to be wandering around with this microphone because I have a laser pointer that I want to get to both sides. Changing thoughts on climate change. I don't need to change your thought. I need you to be able to change your investors' thoughts, because when you walk up to a 55-year-old middle-aged man who watches a network other than CNN or MSNBC, you may have trouble telling them that they should buy a solar fund when they said, hey, I might as well buy clean coal. Ask them, hey, do you want to just buy a unicorn? This change in my thought process has taken me a very long time. Too long, and I admit it. But if you haven't seen Jeremy Grantham's talk from yesterday, it's impressive, it's groundbreaking, and shattering for me. He laid it out in a very, very difficult to swallow form. But Jeremy is 80 years old. He's only been talking about climate change for 25 or 30 years. I'm only 55. So you're telling me there's a chance I can maybe get to 25 or 30 and be as impactful as Jeremy was. If you haven't seen it, please, it's going to be online at some point in time. It is going to be shattering for you. All the opinions that I'm saying right now are my own. CNN tells me not to say anything that I don't want to say. It's not them talking, it's me. And that's always been that way. Even when I did not believe that man was responsible for climate change, they never told me, yeah, you better say it, we're the CNN. They never did. Here's where I grew up, Nebraska. About as far from climate change as you can get. I had a mini bike, I had a BB gun, and I had carbon sink in my backyard. I had more CO2 coming out of the atmosphere from photosynthesis than CO2 going in the atmosphere, certainly until you fed the corn to the cows. And then we have a completely different problem, and it's the north and the southbound end of a southbound cow that you're worried about. The flatulence and the belching is methane. That methane is 20 to 23 times more powerful than CO2 when it comes to climate change. So, here I am. I'm looking at this. How can man pollute the earth enough to kill it? It's not possible. Look, there's only one man on that picture. He's in that building way back there. There's only about 10,000 cars in my little town. There wasn't the impact that we see in big cities like we are seeing now. If the earth warms up, hey, there'll be more clouds. The clouds will block the sun, and that will cool things down. Mother Nature has always evened itself out. We've always balanced. We've gone through interglacials and glacial periods. It's gone up and it's gone down. We've had more CO2, we've had less CO2, and things have always changed. The problem is our input to the planet that we're living on now, and hopefully can continue to live on it, is troubling. The amount going into the atmosphere right now, we can't scrub it out. So at the University of Nebraska, we really believed that ocean acidification was going to be more of a climate change problem than the climate itself. Now I'm not so sure. Now I don't know whether ocean acidification is going to win first, or will the climate change and people will die because of starvation and crop disasters across the world. It's kind of this race. So we are in a race to stop both of those. If you acidify the ocean and you kill the coral reefs and you kill the fish, you've killed the planet. That's where we were. Eventually, we thought that CO2 would never get to 400. It would be 380, and the ocean would just absorb it. It would take it all. As it turns out, when the ocean gets warmer, it can't hold as much as we were hoping. Certainly, we weren't hoping for ocean acidification, but to try to keep that CO2 number down. When you go talk to someone like me, the person that you would have sat next to 5 years ago, or across from, he's going to say, hey, the climate changes all the time. This is a natural thing. It's gone up and down for decades. Didn't you know we used to be standing on a glacier right here? Yep. But that took 10,000 years or more. Some of these interglacials are 50,000 years between the up and the down of what we're seeing now. It is the CO2, it is the methane, it is the greenhouse effect that's putting this temperature. I'll show you where we've been and where we're going in a minute. So yes, the climate changes all the time, but not like this, not in 100 years. What we've seen could have taken 100,000 years. We're responsible for that increase in density. They predicted global cooling. Oh, that was a good one. And that's going to be a good one. You can't get away from that one. I don't know why it's still out there. In 1975, a man wrote a little article for Newsweek. It was 9 paragraphs long that was picked up by other newspapers and articles, and even some scientists picked it up, saying, hey, we're cooling down. We're going to an ice age now. We are going to be in trouble because we're going to be covering up cropland with snow and glaciers. Then somewhere around 1980, we realized, yeah, that's not true. So everyone that said, hey, wait, you just told us it's cooling, now you're telling us it's not, now you're telling it's warming, I don't believe you because you weren't right the last time. You're going to get that. It's the sun. The sun is warmer now. There's more sunspots. There's more radiation coming in. No, the sun's the same. The sun's been the same for billions of years. The Antarctica is gaining ice. Yeah, sure, the Arctic is losing some, and the polar bears are going from one little iceberg to another, but the Antarctic is doing fine. No, it isn't. Shelves are breaking off. Everything is happening globally. That's why we call it global warming, not New York City warming or Atlanta warming or Miami. We can't forecast for 10 days. How do we know 10 years? Well, that's a good one, because the models that we had back in the 70s and 80s were horrible. You could run them on your iPhone right now. Now, the supercomputers we have are significantly better, and our weather modeling is probably out to 5 or 6 days, pretty darn good, plus or minus 3 or 4 degrees. Sure, we'll miss a snowstorm here and there once in a while, but that's because of resolution. Resolution, let's pretend that this is the globe right there. The models into the supercomputer will put 9 layers of atmosphere above the Earth. Are there 9 layers? No. Are there 15? No. There's an infinite number of layers in the atmosphere. Try to put infinity into a computer and see how long it takes you to hit Alt-Control-Delete, because it's going to hang up. You can't get to that resolution even if we tried. But let's say we put 30. Let's say we put 40, whatever, and we shorten the space between data points from 5 miles to 3 miles, whatever that might be, to try to get a higher resolution data. And we can do it. The problem is, if we put it into the fastest computer in the world, that computer model takes 60 hours to make a 48-hour forecast. So I can tell you what happened yesterday, which is useless. So we cut that off. We cut the time off at somewhere around 2 hours. We let the computer run for 2 hours. When we get a faster computer, then we can put more in, then we still get 2 hours, and the computer's a little bit better. And this is something that I worked on when I worked for the National Weather Service back in D.C. back in 1985. It has been warmer in the past. Yep, it has. Let me see. I just looked. World-o-meters. There are 7.660 billion people in the world right now, according to this website, and it kind of counts up, and then they reset every once in a while. Unless you believe that Fred Flintstone trained a dinosaur to move rocks in his mouth, the last time we were this warm or going where we're going, the number of people on the planet was 0. So we are far and away trying to feed 7.6 billion people on a fragile and becoming more fragile planet. And the cities are hotter, and so the thermometers are there, and that's wrong too, because now we do this on the satellite. The satellite measures the temperature of the surface of the Earth, measures the surface of land and water, and now we know from the time of the satellite to now that the Earth is warming. So here's what the global temperatures are, and I will try to explain a couple things to both sides. Here's that little area of global cooling that they talked about, 1975, that little spike right down there. That's about 1/10 of 1 degree Fahrenheit cooler. 1/10. Then all of a sudden after that, I think we're up to, 0.4, and we're going up from there. So this 9 paragraph article that was written about this little blue area here put a world of doubt in the people that want to believe in global warming, but we were wrong the first time, so is it really global warming or global cooling? There's another thing you'll hear. Hey, it hasn't warmed since 1998. 1998 was warmer than we've been. I don't know where that came from. It was a warm year. It's here. That's 1998, right there. And that was an El Nino year, and it was brutally hot compared to the years before that. See how quickly it went up right there. But as I advance, we'll try to find 1998 on this graphic. It goes in not chronological order, it goes in temperature order. 1998 is way over there on the left. We have been warmer in 2009, 13, 05, 10, 14. This year we're still somewhere in this 2017 range, and 2016 was truly a brutal year for ocean, land, and global temperatures. And you can see it in sea ice, you can see it in glaciers melting, you can see it in droughts, you can see it in heat waves, you can see it in flash flooding, because a warmer planet can hold more clouds. Remember that? A warmer planet can hold more clouds, so the clouds should come in and block the sun. That was a theory that we had that didn't work. But when you get more moisture, more humidity in the air, and you get something like Harvey that sits over an area, that's the one that hit Houston, Hurricane Harvey, and it has that much moisture in it that you can get 60 inches of rainfall from one storm, all of a sudden, yes, the earth can hold more humidity, and there it goes, right in one spot when a storm doesn't want to move. And 2017 was brutal with Harvey and Irma and Maria, and Mr. Grantham yesterday talked about El Yunque, which is a very nice tropical rainforest in Puerto Rico. I visited, and 25 years ago, it was really amazing. When I visited, it was like, really? This is it? After Maria, it doesn't exist. It's gone. So it's global. It's northern hemisphere. It's southern hemisphere. Why do we care? Because there's a lot more water in the southern hemisphere than there is in the northern hemisphere. There's much more land. You have Asia, you have Russia, you have North America, you have Canada, all north of the equator. You only have a few land masses south of the equator, so it's not just one thing. So where did I change my mind? And I'll get this all the time, and you can ask it too. What took me so long to figure out that man was the only cause? Man was the only possible explanation of burning this fossil fuel. It was the number 400. When the Mauna Loa Observatory got to 400 parts per million, I knew the world was in trouble. Was I tardy? Sure. Will I try to make up for it? Absolutely. But now we're 410 and going higher. Globally, it's a little bit less than that, you average it out. But Mauna Loa up there. And it gets higher before the northern hemisphere gets crops. Because when the northern hemisphere is in its winter, you don't have that carbon sink of all the crops that are in the northern hemisphere growing. So your peak is somewhere always in May or early June before you start to get the photosynthesis. And this is the issue right there. We're 400 and going up. We talk about the hockey stick. The hockey stick, if you take this and you would take this all the way across here, it's even. I'll show you that in a second. And all of a sudden, this white line, the parts per million, takes a left-hand turn from 300 to 400 and where we're going from here. Has that been higher? Yes, absolutely. Have we been higher from here? No question. You've heard of the Jurassic period. You've heard of Jurassic Park. That's when all of these plants were growing and all of this CO2. Why aren't plants growing more and taking the CO2 out? Because we are overwhelming the plants with the amount of CO2 that we're putting in it. They can't take it out fast enough. The ocean can't absorb it fast enough. So now I'm going to get technical on you, and right there, that's the Jurassic period. We were about 6 degrees warmer than we are right now. Millions of years. Let's just call it 100 million to be safe. The world was a wet, tropical place. After Pangaea split up and now we have two continents going one way and the other, we had a lot of land in tropical rainforest areas. And for 100 million years, those carbon sinks, the ferns, the plants, the trees, all were sequestering CO2 in the ground. They rotted, it was underground, it was underwater, it was buried. And what are we doing now with 100 million years worth of carbon sequestering? We're taking it out of the ground and we're burning it. We're putting all that carbon, that 100 million years worth of sequestering, put away. Wow, it's hard to think about that. So there's our oil. And then we got really hot, and we can't even find any ice cores hotter than this, and this is about 50 million years ago. Don't know really what the carbon dioxide was there, but probably somewhere over 1,000, pushing 2,000. Because there are no ice cores to look at, we have to go down into the seabed to see what the coral looked like, see what the ocean looked like, and what the little shells looked like, because when there's CO2 in the atmosphere, there's CO2 in the ocean, which means the ocean is acidic. If the ocean is acidic, these little things that need to grow calcium can't grow the calcium properly, and so we know by the lack of shells that we had some pretty high CO2 in here. We come back down here, and right here through the Pleistocene, up and down, up and down, up and down, so both ways right there, those are glaciers. They came and they went, and they came and they went, and you can find glacier moraines in Ohio, and I love some of the ones that are in Pennsylvania. Glaciers went back and forth across the globe from top to bottom, and bottom to top, in fact. As we came out of that, we're kind of into this interglacial area here. See how these numbers are kind of tight together, and then we space them out. For the past 10,000 years, for the past 10,000 years, all of a sudden, we have been pretty flatlining for where the temperature has been. This is the Goldilocks. Not too hot, not too cold, just right. And this is where man has come through. This is where man lives right now. Unfortunately, we're not here anymore when it comes to CO2, and we're not there anymore when it comes to global temperatures. Those global temperatures are going up. So I've kind of expanded the timeline so you can get a feel for, this is millions of years ago. We came down below 400 parts per million somewhere about 1 million years ago, and we haven't gone back up above that truly since. This is 45 million years ago. There's a spike possible. Nothing's perfect here. That's why it's such a wide range, but possibly 200 parts per million, ranging all the way up to 2,200 parts per million. So are we in uncharted territory? Yes. Have we done it? Yes. Is man responsible? Yes. It's not a volcano. It's not anything that global deniers, I was one, believe. There's nothing else out there. I've ruled it all out. And I said to myself back in the 80s and the 90s about thinking about this now, a little bit of knowledge is a dangerous thing. And that's what I had, a little bit of knowledge. Because I did weather. Weather is day in, day out. Is it going to be 42 or 47? A weatherman is not a climatologist. A climatologist looks at things over time. I look at my time to be a 24-hour or a 48-hour forecast. So when I started digging into this in 2008 and 2009, and there's an organization called Climate Matters, Sean Sublett will help you with anything you ever wanted to know about the climate, and he is available pretty much almost every day of the week because I call him on Sundays. So here's where we are now. 400,000 years ago, we have not been above 300 parts per million. How do we know that? Because we do have ice cores here. We can dig up the ice, look at the bubbles in the ice, and find out how much CO2 is in that ice. So yes, we are really sure about these numbers, and that's why there's not the big spaces between, is it 200 or 2,000? We don't know. This is right on the timeline. When we get to the Industrial Revolution in 1890, 1900, 1910, that's when the CO2 starts to ramp up. Higher than we've seen, higher than we want right now. What can we do about it? Is it over? Do we have a chance? I have a 14-year-old son. I tell him all the time, dude, your world is not going to look like this. Your world is not going to look like mine. And what we're seeing now, and we can go fishing every day, and we can do whatever we want. This world is going to be different. If you believe 10,000 people coming from Central America across a road in Mexico is a migration, wait till 2 or 3 billion people start to starve, and what's going to happen to that migration? That's the reality of where we're going if we can't fix this. We are 1 or 2 crop failures away from millions to billions of people starving to death. And I don't want to be Debbie Downer on that, but that's reality. And that's why it is so important for all of us to get forward-thinking people with us, to get people that would never consider investing in green or impact investing. We need to get them on board. I don't know how we do it. I don't know how we could get this to everyone who needs to know it, because we all need to know it too, but we already pretty much knew it. So here's what it's the people that don't know it that really would like to, I think, be impact investing, and they're just not. They just don't know why they should be. So what do we expect from global warming? Well, what do we already have, really? We have water vapor in the air. It's higher than it's been. We call that dew point. Dew point is the temperature of this ice water here. If I pour this ice water in this cup and I get condensation on the outside of that cup, the dew point is 32 or higher because the water temperature is 32 and there's an ice cube in there. It's not condensating, so dew point is probably somewhere less than 30. It's dry out there. If your lips haven't been chapped, I've put like 3 coats of this stuff on. But I live in Atlanta, where the humidity never goes down. Sea surface temperatures are up. The ocean temperature is up. Ocean heat content is up. 2 days ago, finally got a report back from an ocean-going vessel that has been dragging its sensors across the ocean back and forth. Not only is the sea surface temperature that we talk about in weather, because that could make a hurricane worse, not only is the sea surface temperature getting warmer, that warm water is sinking to the bottom, and the layers in the ocean are also getting warmer, which is, of course, disturbing. The temperature over the land and near the surface of the land is getting hotter because of the sun not hitting anything down here, like a glacier or snow cover or sea ice, because they are all going down. The ocean has gone up about 8 inches since 1900. Half of that has happened in the past 20 years. So back up to this hockey stick ramp. Where do we go from here? I was in Miami Beach 2 years ago doing a story on king tide. And I'm standing on South Beach, and they said, hey, let's go, because king tide's coming, let's go to Whole Foods. Well, that's random. Why are we going to Whole Foods? Because you'll see, they have to use squeegees to keep the water out. Oh, okay. So we went on the backside of the beach, kind of, by the bay, back bays, whatever that's called. You can see Star Island from all those places. And sure enough, the water's coming out of the sewers. The water's coming up and downhill, down to the bottom. And what's at the bottom of the hill? Whole Foods. And they just built this. I go, they didn't build it on stilts? They go, no, man, this is going to be Venice. We are going to see water in here even without king tides. And the water was only probably 9, 10 inches deep. Not significant at the time. But if we keep warming the ocean and we keep melting glaciers, that water is going to go up more and more and more. We didn't even have an east wind to blow water in like Venice had a south wind to blow water into that flood that they just had a week ago. Now, this is not in Venice terms, it does happen. There's even a name for it. It does happen, but to see that much water in places opens your eyes. It hasn't happened like that since like 1938. So it's not the worst they've ever had, so it's been worse. That's another one. Oh, you know what? It's been hotter before. The water's been higher before. That's still not a valid claim. So here we go with all the things that are going to happen as the ocean heats up. How do we know it's heating up globally? Not only satellites, but we can tell you from city to city, record high to record low. 2016 was brutal. 5-to-1 ratio of record highs to record lows. We're not getting cold nights. We're not getting winter kills. I have a friend who sells pharmaceuticals to veterinarians in North Carolina, and they've never seen so many ticks this year as they saw because they just didn't get killed. The population density with the ticks and, of course, fleas, but the ticks, they're more important because of what they can carry. So Heartline, Front Guard, whatever they give to these animals to keep the ticks away. I went to go look at a little lake property in Georgia, and it was a little crappy little cabin for $68,000. I got out of the car to look at it with my son because it had a lake, and he just wants to fish all the time. And there were 10 ticks on my leg by the time I got back in the car. I went, oh, we're not buying this place. Not coming anywhere near this place. So 2018 wasn't quite as bad. Right now, 2-to-1 ratio, record highs to record lows. But here's this issue of why I used to love growing corn on my corn farm in Nebraska. Now maybe I don't love it so much. 1 ton of methane is the same as 23 tons of CO2 in the atmosphere when it comes to heat holding effect with global warming and the greenhouse effect. Now, if we didn't have any CO2, our temperature would be like 0, and even sometimes say 40 below 0 without a greenhouse effect. And there are planets without CO2 that get that cold every night. So CO2 is not our enemy. The number 400 or 410 or 420 or wherever Dr. Grantham was going at 500 and 550, that's certainly our enemy. Livestock, depending on the number of creatures on the planet, ranges from 14.5 to 18% of the methane released compared to 14% of transportation. Now you take that cow and you put them in a truck and you drive them around somewhere to drop it off at Costco, you not only have the methane, but you also have the CO2. This is a graphic that I have to explain because I didn't make it, and the person that did make it was not a math minor. That's not megatons, thank God. That should just say tons. I just didn't catch it in time to send it here. If China sent out 10.3 billion megatons of CO2 last year, we wouldn't have time for lunch. It would be over. That's 1 million times more than they actually did. So just pretend that mega isn't there and we'll take tons. This is something else you're going to get because my friends that I live around will go, why would I ruin my economy by taking CO2 out of my businesses if China's not going to do anything about what they're doing? I kind of sit there and nod. I went, yeah, you know what? The pollution in Beijing is pretty bad. You can see it on TV. It's unhealthy many, many days out of the year. Something the U.S. would never put up with, or we would shut down the plants. So here we go. Let's make sure we know that this is only tons. 2.1 billion tons in India last year, 3.7 in EU. Ooh, the European Union's doing really good. They have little cars, they walk, they take the train, they don't eat very much. They're all skinny. So, wow, 3.7, that's awesome, that's amazing. I told you, look at China, 10.3. We're doing so much better, we're only 5.3. Now we look per person, and we'll see who the polluters really are. There's us. They didn't put the mega in this time. 16 tons. Remember how good EU is doing, 7.3? That's exactly per person what China is doing. And a developing country like India is still at 1.7, but growing rapidly because of their industrialization, their rapid increase in economy. India is doing very well, and that may be a source of added CO2 in the future that we'll have to deal with at some point in time. But where are we looking for the problems coming up in the world? What if we already know CO2 is there and global warming is happening and we're still trying to stop it? What's the real rub, weather-wise or climate-wise? We're going to have heat waves. Well, that's pretty much a no-brainer because we're already 2 degrees above where we were before we started burning oil. We're going to have coastal flooding. I was standing in it in Miami because the water came up in the city that used to be dry. Why is the water coming up so much? Because the water is warming as well. What happens when you put your hand on a thermometer? What happens to that yellow or red or silver liquid that's in that thermometer? It goes up. When liquids get warmer, they expand. We're expanding the ocean volume because we're warming the ocean volume, and that's another reason why the 2-day-old vessel dragging through the ocean report that came out 2 days ago is so disturbing, because we're not just warming the top 50 meters, we're warming down below as well. We are going to get floods. There was nothing I could do to get over what happened to Houston and Harvey with the inches and inches and inches and the days and days and days that were on TV about this. And I don't get on television a lot on CNN unless we get weather like this, because Donald Trump puts out a tweet and all of a sudden we're 24 hours worth of breaking news. This flood that Harvey did to us was not even once in a lifetime. This is once in never. Once in never could we ever get 60 inches of rainfall in one space, in one place, trying to all run off. It's low-lying, yes, it could get into the ocean, and much of that 60 was close to the ocean, but you saw what happened to Houston itself. We are going to get droughts. We are going to get crop-destroying droughts from the heat waves that won't allow the rain. And we talked about, hey, you know what? If we get humidity in the air, won't we get more clouds? Won't we block off the sun? Won't we get cooler? The problem is that if you take the atmosphere and you warm it all the way through to the top, you don't get those bubbling clouds because it's warm up here too. If we could get the cooler up here, then you get a bubbling cloud, you get a big cumulus cloud, and that's a great cloud. But when you have a warmer temperature at 20,000 feet or 10,000 feet than you should, the clouds don't develop. So we do know that hurricanes will likely be stronger, but not a lot of evidence because we haven't seen it. Yes, we had a terrible year, 2017, with Maria, Irma, and Harvey. That was somewhere in the neighborhood of $260 billion worth of damage from those hurricanes. But it isn't that we haven't had a year like that before. We have had years like that before. 1938 in particular was a devastating year for hurricanes. So how can you say that something that happened 80 years ago that was equal to something that happened 70 or 80 years ago is equal to now? Is it really testimony or anything that's true? A scientific journal could not tell you that hurricanes are getting stronger. They're getting wetter, but they may not have more wind because we have a limiting effect on the size of the Atlantic Ocean. If you ever see me talk about super typhoons on CNN International, they're unbelievable. They're 195 miles per hour. They just get crazy out there because the Pacific Ocean is so much bigger, it's warm, and it has the room to run. Those typhoons have room to get going, and they continue to go. Have we had more tornadoes, or have we just had more tornado chasers? That's always been a big question. Somewhere around 1,000 would be the number for the U.S. I did stand out there in the last tornado that I will ever stand out there in, which was El Reno, Oklahoma, when the wind speed was 317 miles per hour, and I was 1 mile away. That's the last day I'll ever do that. So we're going to have increased cooling demand, clearly about 20% from 1970 to where we are now in Phoenix. So that means decreased heating in Minneapolis. Maybe that's a good thing. But here we go with Miami, the humidity, and also these spikes that can kind of get you from 40 to 100 cooling degree days. And it's how much do you have to heat your house or cool your house compared to heating degree days or cooling degree days. So yes, likely New York and DC and Cleveland and Detroit and Chicago will probably have a lesser demand for heating, but they actually may find that they need some cooling that they didn't need before. I grew up in Buffalo until I was 13 years old and moved to Nebraska, and we didn't have an air conditioner. I was never hot. I was a kid, but we were never hot. So are there any positives? Is there anything that we can come to grips with that said, hey, this isn't so bad. We might get by with this. Well, the longer growing season may help. We may be able to grow longer crops, which may give possibly longer yields. And that's right here, Peoria, Illinois. Here is Tupelo, Mississippi. Mississippi has the opportunity to something called double crop. Double crop is when if you have 260 days between frosts, you can put in a winter wheat or something that will grow in the spring. You tear it out when it's done and you plant a second crop and you get two crops on the same piece of land. Unless all of a sudden you don't get 260, you get 200 and your second crop is a failure. And you dig it up and you plow it under the ground and you don't get anything for that second crop. Here's where we've been since 1980, somewhere between 3 to 5, $1 billion disasters per year. This is cost adjusted. 2017 had 15 events worldwide that cost more than $1 billion US. And the 3 hurricanes that I mentioned were somewhere now still in the ballpark of adding it up at $260 billion worth of devastation by those 3 storms. So did we have $15 billion disasters or did we have $260 billion disasters? Because when they get that high, it does get scary. If we don't get snow in Oregon, I can't have beer because it runs off and they take the snow and it gets into the rivers and they irrigate my hops. So what can we do? We can scrub CO2 from the atmosphere. As a person, it's hard to do unless you're planting trees or getting with an organization like Atlanta Tree that we try to put trees on as many streets as we can. Yes, it's pretty, but it's for a reason as well. There's also a few companies out there that are truly scrubbing, not personal, these are businesses that are scrubbing CO2 out of the atmosphere. One that really intrigues me is climate engineering and carbon engineering, and it's in British Columbia, and they can literally scrub CO2 from the atmosphere, mix it with hydrogen, and make a liquid fuel that you can pour straight in your car. Much better for the car than gasohol, or methanol, ethanol. And it's just too expensive to make right now. But wouldn't it be great to make a circle where we take it out, we put it back in, and we take it out, and we put it back in. All of a sudden, now we're not polluting every single time we're filling up. You can drive less. I go to work in the morning at 4 o'clock in the morning. There are so many people in Chevy Suburbans or Explorers that are driving by themselves, it drives me crazy. I'm in a little hybrid trying to do my best to not use gas, and these guys are just killing it. And here we go, eat less meat, of course, that's always a thing. Can you just have an 8-ounce filet instead of a 24-ounce porterhouse, maybe? Solar panels for your house and wind power as well. Solar has come down so significantly that it's almost cost-effective to put it in now. And I know very few HOAs that will prohibit you from putting solar panels on the back of your house. Now, if the back of your house faces north, then it doesn't really do much. But it's coming down to the point where it's going to work. The problem with the old solar, and still some of the solar that's being made now, it's such a polluter to the atmosphere, it's almost not worth it. You just have to buy from the correct companies that are actually being investigated or watched by the universities, by the government. Buy local products. I go to my little Ingles, my favorite little store in North Georgia, and I look at their asparagus because I want to put it on my grill, and it says, made in Guatemala. Put it back. I don't need my asparagus traveling 4,000 miles to get to my house, and I have to put it in my car, drive it some more, and then cook it. Buying local is truly the way to reduce the amount of CO2 from the trucking industry. We could also put a lot of things on trains. That doesn't seem to be happening as much as I would like it to. Reduce, reuse, recycle. I can't tell you how many times I've had a bottle of beer or wine and I went, rather than taking it 13 floors down to my basement where I have an amazing recycle bin that I can just separate and everything, but it's a lack of, it's laziness on my part. And I'm sure we all have done it. It's just one thing. It isn't just one thing, because you add all those things up and it isn't one thing anymore. So I hope you have some ammunition to take back with you so that when you're talking to the people that don't want to listen, maybe you have an edge over them. And that was my goal here today, to help everyone understand how to get to people like me, because if I can change my mind, ask my wife, that's a really big deal. Once my mind is made up, it's pretty hard. And we're fighting an uphill battle with many respects for where we're going here, from politically to the other side. I won't get into that. But I need all of us to get together, and if we can, they tell two friends and they tell two friends, remember that shampoo commercial? And so on and so on and so on. Thank you all.